Welcome everyone to this first webinar series on Industry 4.0 and developing countries. It's a pleasure to have this audience. And in this first webinar that we are starting today, we are going to deal with what is Industry 4.0, mapping its actual relevance and potential for growth. And we have great speakers joining us today. Thank you very much, Lili Wang and Alejandro Lavopa, for joining us today. I'll start by briefly introducing our two speakers, and then each of them will have 20 minutes for presentation. And after that, we will open up the room for questions from the audience. And for that, in order to try to keep it organized, the idea would be for you to write down your questions in the chat, and then we proceed to the answers. So once again, welcome everyone, and thank you for joining. So our first speaker, Lili Wang, is a senior researcher at UNU Merit. She obtained her PhD degree from Eindhoven University of Technology and joined UNU Merit in September 2008. Her research interests cover a broad range of areas, including economics of innovation, emerging technologies, science and technology indicators, international collaborations, and knowledge spillovers. She has conducted various research projects since 2008, and her work has been widely published in peer-reviewed journals, such as Research Policy, Proceedings of the National Academy of Sciences of the United States of America, Regional Studies, Technological Forecasting and Social Change, Journal of Infometrics, Industrial and Corporate Change, Journal of Technology Transfer, Oxford Development Studies, Research Evaluation, Journal of Technology Management in China, and the International Journal of Technology and Management. And she's also a reviewer of more than 20 top science and technology journals. Alejandro Lavopa works as a research and industrial policy officer at the development of policy research and statistics at UNIDO. He is responsible for engaging in research activities and providing industrial policy advice with particular emphasis on issues related to economic growth, structural change and industrialization. And among other tasks, he coordinates UNIDO's flagship publication, the Industrial Development Reports. He obtained his PhD in Economics and Policy Studies of Technical Change at UNU Merit. And before joining UNIDO, he worked at the Argentinian Ministry of Economy and also in Buenos Aires University. And recent publications include articles in journals such as World Development and Structural Change and Economic Dynamics, and chapter contributions to reference books. Now we will proceed to start with Lili's presentation. So Lili, the floor is all yours. And once again, thank you very much.
Hi, everyone. Good afternoon, good morning, good evening, no matter where you sit. So thanks, Florencia. Thanks for the invitation. It was very nice to give a presentation to this group. Yeah, I have been working in this innovation field for about 20 years. So I feel more and more pressure actually in recent years. Because as a researcher, we also need to react very quickly to the demand for the public policy related to the new kind of technologies. So I think this seminar, this kind of presentation, I think is also will give you kind of feeling what it means. The industry 4.0 for us, and how we are going to do with it. How should we react? Okay. So first, I would like to briefly mention the meaning of Industry 4.0. So this term, Industry 4.0, actually was originally from a German project in 2011. And so it's related to the high-tech strategy of for the German government, and related to the automation, to promote the automation in manufacturing. And then this also related to, go to the next one. This also related to a set of concepts related for this industry 4.0. For instance, using the modern smart technology to produce to achieve the automation of traditional manufacturing and industry practices, the basic meaning for this industry 4.0. And it covers quite a lot of important elements, such like data exchange and cyber physical systems, Internet of Things, cloud computing. So this Industry 4.0 also changes the concept of manufacturing from the earlier mass production to the more kind of more personalized production. So Industry 4.0 sometimes also referred to the fourth industrial revolution. It's also called a smart factory. So talking about the fourth, if we often refer it as the fourth industrial revolution, of course, we need to link up with the earlier industrial revolution to see the new features of this industry 4.0. If we briefly look at the earlier industrial revolutions, we see every time the industrial revolution took a while, for instance, like sometimes almost 100 years. For instance, like the first one, industrial revolution associated with the water and steam powered technology started from the UK from 1760, and it lasted quite long, almost it's really like 70 or 80 years. And then if we look at the second industrial revolution related to the electricity, and also related to electricity, but also there are quite a lot of other associated technological innovations. So at that time, people had some mass production, and then also the car industry started from there. And then the third one, starting from 1970s, related to the electronics and IT. So we know from then we start to use computers for our study, for our work. And then the latest one, fourth industrial revolution, covers a much broader set of technologies, including the 3D printing technology, Internet of Things, nanotechnology, artificial intelligence, robotics, or biotech, neurotechnology, or energy blockchains, cloud computing, etc. So a lot. But if we summarize the key elements for each industry revolution, we can see the first one is water and is related to water and steam power. And the second one is related to electricity. And the third one related to computer. Computer give you lots of power to do calculation, to do your work. And then the fourth one is more related to the algorithm and automation. So it's a kind of a digitalization of manufacturing. This is the key part. That's why people often say Industry 4.0. Actually, Industry 4.0 is a bit narrower than fourth industry revolution, because in fourth industry revolution you also have nanotechnology, also biotechnology. But the Industry 4.0 is more related to the automation part, the smarter manufacturing part. And then if we look at the common side of all the industry revolutions, we know from the beginning what innovations were meant for. So actually, we know that the innovation was always meant for labor saving purpose, and to release labor from kind of heavy work, physical work, to do other things. And then, of course, related to this, you save some labor from certain kind of activities, then you need to think of where to put the labor. And then you have the change of manufacturing regimes. And so following that, of course, we also have the adjustment of the human capital. So this is a common feature of all the industry revolutions, including this Industry 4.0, of course. However, if we see that the earlier industry revolutions, it took 70 years, 80 years to have the full round. But now every year we have different things. For instance, like the deep fakes. Last year was not, we knew that concept, but this year you see everybody is using it. So in this new kind of industry revolution related to the Industry 4.0, we do not have that much time to react to it. So this is it's quite challenging for us to talk about labor saving or change of manufacturing structure, etc., to adjust human capital. So that it gives us lots of pressure. So that I will come back later. So related to this feature. Now I want to say that because the new development of the Industry 4.0 related technologies, we have lots of new opportunities. However, we also have lots of kind of challenges or stress from that. And so I want to, in this presentation, briefly mention a couple of examples, a couple of features to elaborate how we should, from which direction we should react, and what this Industry 4.0 mean to us. For instance, the first feature is the emerging countries are involved in this round of the new technology changes. And if we look at the 3D printing technology, this is one of my actually one of my paper, because I also am I'm dedicated to studies related to emerging technologies. And I found actually in recent years, the emerging technology is really very difficult to study because they are changing so fast and so different elements there. Taking the example of 3D printing technology, as we mentioned before, in the industry 4.0, the smart manufacturing, in the smart manufacturing, 3D printing technology plays a very important role there to change from the mass production to the personalized production model. If we see the technological trajectory of this type of innovation, you see from the beginning, US or UK or Germany, Japan were the advanced countries leading this type of technology. And then this is the beginning. It's a bit not really very well developed the trajectory. And then you see in the middle from 1998 till recent years to 2007, there's very uniform the trajectory. Very it's only one line, stabilized. We can say that. And then in later years, most importantly, we should look at the later years because this is related to the future. If you look at the later years, you can see lots of emerging countries are involved in this developing or using this type of technologies, including South Korea and China. Of course, South Korea belongs to the advanced country, but China as a developing country, they are also using or developing lots of 3D printing technologies. So, but this figure doesn't really meant to show only the technological part. I want to say that related to this type 3D technology, 3D printing technology. So what can we see from here? What does this mean, the fast development of 3D printing technology in this industry 4.0? And what does this mean to the global value chain if developing countries are using so much, relying on so much the 3D printing technology? What does this mean for the low-skilled laborers? How can they contribute if they cannot really work as before anymore, and because all the machines can take their jobs easily. So most importantly, like developing countries, are they really ready for this? So I don't know. We have to figure out. So this is one example showing that. Related to the industry 4.0, industry 4.0, there are lots of uncertain future ahead. We have to really think of strategies, think of the ways out. So second one, I want to mention the second feature of related to this a group of new technologies nowadays. So there are also, I want to start from the early technology. If we talk about the early technology, we always want to say that innovation is good. Innovations are always encouraged to solve certain problems, because you have a problem, you can use certain technology to solve it. For instance, in the old days, people have them people didn't want to do laundry by hand, so they develop like a kind of a washing machine, and then problem solved without causing too many other problems. But nowadays everything changed with this new group of technologies. We see when you solve certain problem, when you find a solution for a certain problem, and then you are having more problems for later on, and so you need more solutions to solve this plural problems, more problems around it. This is related, for instance, like the 3D printing application in manufacturing in developing countries. Yes, technology-wise, it's ready. We have the basic technology, we can use it. But what does this mean to the society? What does this mean to a low-skilled labor group? So you may have more problems. You need to think about social protection. You need to think about their job or structure or the industry structure change. So here is again one example of such a type of problems. So the related to the case I just mentioned, because of the application of such smart technologies, we need to think about the structure change. For instance, the robots are going to take our jobs in the future. What kind of direction should we be prepared? For instance, here I gave you a list of types of the education types and related to certain different jobs. I do not go to the details. So the basic idea is that the lower skill you have, the more, of course, it's more dangerous for you to in the future. So you need to really make a transition from your current working type to the future one. And then if you think about the automation jobs in the future, probably you should be prepared, like you already have to think of your education for yourself and for your children. What kind of education might be needed more in the future. Of course, everybody wants to go to go to the well-paid jobs, but are there enough? And also this calls for the actions from education system. So they also need to change their education structures. For instance, put more effort to have the education for the healthcare or like social intelligence types of work. So etc. Just some examples. Here doesn't want to give you kind of solution, but we need to think for the possibilities for the future, and also kind of more problems we need to be prepared beforehand. And then here is the because of the solutions, because of the
to a minimum is very important. Otherwise, it doesn't work.
Okay. So because of the solutions leading to all new problems, so that's why we need the change for the education, like the training from the bottom already, and then to be prepared for the adjustment, and then ready for the future development to increase the competitiveness for the future. Okay, I have 3 minutes, so I will go quickly to the next slide. Another feature I want to mention is the risk related to the data. Of course, everything is digitalized nowadays, and we already realize lots of problems related to privacy or health problems, etc. So while most people think that innovation is an engine for economic growth, we also, on the other hand, we also realize there are more and more dark sides of such new technologies, new innovations, especially related to this I40. And then the lots of unintended consequences from such technologies, more and more obvious to us, to the society. For instance, like the Maastricht University had the cyber attack end of last year, early this year, and to cause a huge damage to the staff's work here. Got a lot of delay for all kinds of work, and caused lots of people's for IT people especially, caused lots of hours for them to fix it. And in the end, the university had to pay even for the to pay, to get in order to recover the system as quick as possible. So of course, such a case that we already heard. And another one I want to bring to your attention is the Alibaba case in China. We know that e-commerce developed so fast in the past years, and we also know that China plays a very important role in changing their positions in the global value chain using such technologies. But why we waited so long to realize the problem for Alibaba? For instance, only last month. Then Alibaba's case is that Alibaba uses the data and algorithm to maintain their competitive advantage and to strengthen their power in the market. And so they basically digitalize everything in the entire retail value chain, and they killed a lot of small firms. And so in the end, they got a $2.75 billion fund. But we may think why we need to wait for so long to realize this, and wait that all the small firms are killed. Then Chinese government start to give this fund to punish Alibaba. So this shows this shows the example that the regulations related to the industry 4.0 really much lagging behind. We are not reacting as fast as machines. We are also not reacting as fast as the development of technologies. Technology can develop really overnight, very quickly. People can apply that. But sometimes we need time to digest what it means for us, and also to develop the strategies. Okay. So in the end, I just want to summarize some more kind of the future forward-looking points. This, of course, this is definitely not a complete list, just related to the examples, the way we could think. We need such a type of reactions in the future. For instance, we should realize that, of course, first we should take the opportunity for such an industry 4.0. There are lots of good technologies, lots of powerful technologies for the economy, for the society. But on the other hand, we also have to realize the problems. And so we shouldn't wait for the damages are done and then start to fix it. That will be too late. So we should realize the problems also from the early stage. And also, second one is related to the such a smarter manufacturing. And we should also really respect the information transparency. This was exactly the case of Alibaba. If from the beginning, if there was the information transparency, and we would not face such a embarrassing situation in the end. Of course, this also means that we need more institution tools. Like even in advanced countries, they do not have such powerful institutions yet. related to the digitalization, related to the big data, or the use of big data, etc. And of course, we also think about for the structure changes. That's always related to the application of innovations in the past, in the first industrial revolution, second or third. But in the fourth one, like I said, it's more urgent. We should react more quickly. And then education, even sometimes in the past, you can wait for 20 years to develop a new education system to change some more courses in the university. But nowadays, we may not have that much time. So we have to think really much ahead. And then also we need to put the effort on the grown-ups education and training, not only in the university, not only in schools, but for grown-ups for the employees, we always need to think of the education, kind of lifelong education and training. And then the last point I want to say is the cooperation. And so the development of technologies can be done by inventors, by certain companies. But those technology can mean a lot to the society. And then we need the cooperation between the inventors or the programmers even, and the regulators from the institution side, from the government side. So all the different parties should work together. And of course, we need more and more. We need more thoughts on this in order to manage the transition, to manage such technologies, to benefit from such technologies. So, any questions?
Many thanks, Lili, for your insightful presentation. I would suggest leaving the questions for the end, and we now we could move to Alejandro's presentation, and then we gather all the questions all together.
Yeah. Okay.
For the questions,
thank you.
You're welcome. For the questions, it would be great if you can either ask your question in the chat or to ask for the voice. That's it. Alejandro, now the floor is all yours.
Thank you, Florencia, for the invitation, and all the organizers. This is a very nice opportunity to discuss very relevant topics, so I'm very grateful for this invitation. And thanks also, Lili, for the very nice presentation. Indeed, I think we did a good timing for the presentation, because what you have presented really paved the road for what I'm going to present. So thank you very much. Let me, first of all, share my screen. Yes. Can you see my screen? Yes, excellent. And now I need to... Okay, so let me start. As you can see, I have tried to align the format of my presentation with the webinar, so I hope the organizers are happy with that. And basically, so the question that was posed is, what is Industry 4.0? And my answer is not going to come from my own thinking, but instead I would going to do a summary of the latest UNIDO Industrial Development Report, the IDR 2020, which actually deals with this particular topic. No, its label is industrialization in the digital age, and it focuses on advanced digital production technologies, which is the name that we use to speak more broadly on Industry 4.0. There you can see the report. And in this report, what we try to do from UNIDO is to combine our own research with inputs coming from leading experts on the field. And in particular, in this 2020 edition, We have built on inputs coming from 14 background papers and in-depth country analysis, including the collection of firm-level data in a subset of 5 developing countries. And we have also conducted 16 case studies specifically on how this type of technologies are being adopted and implemented in firms in developing countries. And I think that an interesting original perspective that this report brings is that it takes the view of developing countries and tries to see how these countries are coping with the Industry 4.0 technologies in their path toward industrialization. So in this presentation, and again, trying to relate with the topic that the organizers have given, that is mapping the relevance and potential growth of Industry 4.0, I will try to guide the content along 5 questions. The first one, which in fact has already been answered by Lili, is what are the ADP technologies? Next, who is creating and who is using ADP technologies? And I think this is a very relevant question because it speaks to this concern that Lili was already posing, but also the organizers in terms of to what extent these technologies are being diffused around the world. The third question is what is needed to engage with this particular set of technologies, and Lili has already talked about some of the conditions which are required to engage with these technologies. The fourth question is why these technologies are important, no? Because that, of course, is one of the main issues of why we are giving so much importance to this particular set of technologies. And the last question, very ambitious question, so don't expect a real answer, but we want to discuss a bit on how can developing countries capitalize on these opportunities which are open by the advanced digital production technologies. So let me go to the first question, and again, I will be very brief here because Lili's presentation already covered most of the material I was planning for this question. But just let me again stress that this particular set of technologies, or what we call advanced digital production technologies, are the latest evolution of digital technologies applied to manufacturing. So it's not something entirely new that has appeared in the last year, but it's something that has been built in a sort of progressive learning process that goes along the previous industrial revolution. As Lili was mentioning, the main technologies that are typically included here are these 6 that I listed here. We have the industrial Internet of Things, we have big data analytics, we have advanced robotics, and this is typically connected to this idea of collaborative robots or cobots. We also have artificial intelligence and machine learning, cloud computing, and additive manufacturing, which is the sort of more general name for 3D printing. Now, as Lili was mentioning, these technologies emerge from the engineering and organizational principles of previous industrial revolution. So I think this is very important, and I would really like to stress this, that we are facing a process of cumulative technological learning. No? So in order to be able to enter in this sort of 4th industrial revolution or in this Industry 4.0 technologies, countries and firms first need to master those technologies which are coming from the previous revolution. So it is very important to build this type of capabilities from the previous industrial revolutions to be able to enter in this ongoing technological revolution. And this is one of the main points we want to stress in this report. And one other point which is important to keep in mind is that to be fully operational, these technologies, they need to combine 3 components. So on the one hand, we have the hardware, which was one of the things that Lili was mentioning. We have the robots, we have the 3D printers. But then to be fully operational, these technologies, so the hardware needs to be also connected with other hardwares, and this is the dimension of connectivity, which is given by the sensors, which are included in the machinery, and the Internet of Things, which is the one allowing machines to speak to each other. And there is also the need for the software who is going to organize all this process. No? And here we're thinking of big data analytics, but also, and more importantly, machine learning and artificial intelligence. And when all these elements come together, they give rise to what is called the smart factory, which is indeed the latest change in industrial production. And that's what is always typically labeled as Industry 4.0. So now let me move to the second question, which is who is creating and who is using this type of technologies. And one important message that we try to give in the report from the analysis we have been doing is that similar to past revolution, these technological breakthroughs that we are seeing today with advanced digital production technologies are again dividing the world between leaders, followers, and laggards. And even though I kind of tend to agree with the point that Lili was making, that these emerging technologies are also included in some emerging countries, what comes out very clearly is that these technologies, at least the production and creation of these technologies, is very much concentrated. And in fact, it seems to be concentrated in 10 economies. No? And what we have done in the report is to combine data from patents, so let's say innovation activity, together with data on trade, which help us knowing not only who is creating these technologies, but also who is producing capital goods which embedded these technologies, and they are, of course, sell around the world. And as you can see in this figure here, okay, that was not expected, yes. As you can see in this figure here, we have these 10 economies, which include the United States, but also Japan, Germany, France, Switzerland, United Kingdom, Netherlands. And indeed, there is these two more sort of emerging economies that Lili was mentioning, China and the Republic of Korea. These 10 economies explain 90% of all patent activity that has been done in these technologies in the last 15, 20 years. Okay, so the development of these technologies is very much concentrated in a few countries. And similar, we can see that when it comes to exports of capital goods embedding these technologies, 70% of these exports are also concentrated in these front-runner economies. Also, the picture we have is huge concentration. And what we can observe at the global level is also visible within countries when we look at firms. And this is coming from a survey that we have conducted for the report, in which we try to distinguish the level of digital technologies that the firm are using in their production, in their operations. And we make a continuum from, let's say, not using digital technologies, which would be what we call generation 0, to using these 4.0 technologies. No? And what you can see, and this is for a sample of countries for which we were able to conduct the survey, so we have 5 developing countries. You can see that in all of these countries, even the more advanced of the 5, which is Brazil in terms of the use of these technologies, the use of these technologies has not even reached the 5% of the sample of manufacturing firms that we have been interviewing. Which means that what we see within countries is also a picture in which we have sort of islands of modernity which are coexisting with a sea of backwardness. Because not only there are very few the firms that they are using these technologies, but also it's very interesting to see that most of the firms, they're either not using digital technologies at all, or they're using very obsolete digital technologies. Okay, so this means that even if there are some companies which are using these technologies, the digital gap with the rest of the economy is so big that then it hampers the possibility of these leading firms to link backward domestically. You know? So then the potential of these technologies to actually support the process of broad-based development is lower. Now, we see this picture in which the creation and engagement with technologies is very concentrated at the world level, also is concentrated within countries. The big question we pose is, okay, what is needed to engage? And what we find in the report is that beyond framework conditions, which are related to, of course, the necessity to have digital infrastructure, to have physical infrastructure, and the appropriate skills, of course, to use these technologies, the labor force needs to have skills related to STEM and related to human-machine interaction and these highly sophisticated skills. One other condition that stands out as very important is the experience with industrial production. And this comes back to my comment before that countries need to already have capabilities on what was going on in the third industrial revolution in order to enter in the fourth industrial revolution. And this comes very clearly when we look at countries, and this is based on the categorization of countries that we have done for the report that I was referring to before. in which we divide countries according to their level of engagement with these technologies, looking into this patent activity, export activity, and import activity. And basically, we distinguish 6 type of countries, going from the front runners, which were these 10 countries which are at the top edge, and they are creating and moving the frontier in this technological field, to the laggards, which are countries which are not even engaging at all with these technologies. But in between, we have followers, which are already starting to engage, and latecomers with at least they present some activity. And here we divide, okay, we say economies which are either followers or frontrunners, we call them economies which are actively engaging with these technologies, and the rest, they are not actively engaging. And what we show in this figure is what is the average level of industrial capabilities that one can observe in these economies. And these industrial capabilities are proxied by the UNIDO Competitive Industrial Performance Index, which is an index that tries to combine different indicators to show what is the level of industrial capabilities of the country. And what comes clearly is that as we move from laggards to latecomers to followers to frontrunners, there is a clear increase in the level of average industrial capabilities, which seems to mean that there is a sort of a stairways of industrial capabilities that countries need to climb in order to enter and upgrade roles in this fourth industrial revolution. So again, importance of having already industrial capabilities in place. And what we have seen at the level of countries looking at the world is also visible when we look at firms. And you remember there were some firms which are actually already engaging with this type of technologies. And we have done some econometric analysis, looking into microeconomic data. And basically what we were trying to analyze is what type of capabilities are required to be able to adopt new technologies. And in particular, we distinguish 2 broad sets of capabilities. Capabilities related to production, which are capabilities gained through past experience with industrialization, so through learning by doing, learning by producing, and capabilities related to investment and technology, how much you invest in R&D, how much you invest in machinery, how much you invest in skills, and so on and so forth. And what was quite surprising and interesting is that production capabilities, those acquired through experience, tend to be more important even than investment and technological capabilities. So this again points to the fact that building industrial capabilities seems to be a prerequisite in order to enter in this fourth industrial revolution. Now, the next obvious question is, okay, what the fuzz? Why is so important to try to enter in this technological revolution? We have seen that the conditions to enter are very difficult, that you need to build capability, so why so? And what we argue in the report, and also we provide some evidence, is that in fact, with all the, we know all the risks that Lili was already mentioning, but these technologies have the potential to achieve certain goals which are very important also for the industrialization of countries. First of all, these technologies have the potential to foster industrial competitiveness through gains in production efficiency. And here you can think on how data-driven decision-making actually improves the productivity of firms, how predictive maintenance can actually improve the production efficiency of a firm, or how collaborative robots are increasing the productivity of those laborers which are already in the shop floor. So all these elements tend to improve the competitiveness of firms. And here the problem is that those countries, those firms which are not entering into these technologies, they will start lagging and lagging and lagging behind compared with the countries which are already there. So then not entering seems not to be an option indeed. On top of that, in fact, this technology can also, in a way, support social inclusion through job creation. This is quite a sort of challenging statement that we are doing here, but our analysis showed that when one considers all the indirect effects and induced effects of these new technologies, they can be net creators of employment, because it's true that they will destroy jobs at the shop floor in the factory, but there is also a multiplier effect, because then there are a lot of jobs creating in all the supporting activities which are required to put to work these smart factories. So then think, for instance, in the jobs created for produce the IT solutions, the software design, or even to create the advanced equipment. So there are also these possibilities of creating jobs through these technologies. And another point, which is also very relevant, especially in today's discussions, is that these technologies also have the potential to render industrial production more sustainable through better use of energy and better use of materials. And this is a very important point. It's something that we have allocated quite an effort to try to analyze in the report. For instance, the use of smart sensors in production can maximize the energy efficiency of a factory, and that is very important. Or the use of 3D printing allows firms to create components which are lighter and therefore will make the material of the final product much more efficient. No? So these technologies can really help rendering industrial production more sustainable. And one last point that this is was not included in the report, but we have included in the work that we have been doing in the last year, of course, after the pandemic. Something we started noticing is that these technologies also have the potential to strengthen the industrial resilience, to be better prepared for unexpected events. No? And this came clear when we look into, of course, remote working in the context of the pandemic, but also digital solutions for online sales and so on and so forth. There seems to be a correlation between the level of digitalization of firms and how much they have been hit or not by the current crisis. So in view of the time, I will go through some of the findings. I think this is interesting also for the discussion. So we said the first point was that these technologies can foster industrial competitiveness through gains in production efficiency. This is not only something that we imagine can happen, it's something that is already happening. And in the report, we look, for instance, in, okay, what might be the effect that these technologies are having already at the level of productivity growth and manufacturing value-added growth across different countries. And again, we use this sort of differentiation that we have done between economies which are already actively engaging with ADP technologies and the rest of the economies. And what you can see very clearly is that both for real manufacturing value-added growth, but also more significantly for productivity growth, in each of these categories, so we have distinguished between high-income economies, upper middle-income economies, and low-income economies, just to have sets which are more comparable across each other. You can see that those economies which are already engaging with these technologies tend to have a sort of productivity premium. So this is already being reflected in the data. And also, when we look at our microdata and we explore the firms and we use this category of firms that we have, okay, according to what digital technology they're using, we also observe that the adoption of the latest generation of digital technologies, in this case, generation 3 and generation 4, provides a premium to the productivity of the firm. So we run an econometric analysis, we try to analyze what is the effect of different determinants on the productivity of the firm, the marginal increase in productivity. And what we see is that even after controlling with several factors, which of course will determine the productivity of a firm, such as the size of the firm, the level of skills, the participation in GVCs, or investment in R&D, the adoption of advanced digital production technologies continues being one of the main determinants of the productivity of the firm. So again, both looking at the macro level, looking at the micro level, we find evidence that these technologies are driving increases in productivity. Now, second element I was mentioning, it was related to social inclusion. As I mentioned, this is a bit more controversial and it goes a bit against to one of the elements that Lili was highlighting about the impact on employment. What we find is that these technologies, yes, it's true, they are probably posing risk to the jobs that we have now, but they can also be net creators of jobs. No? And for instance, an exercise that we have done is to try to analyze at the world level what has been the effects on the creation or destruction of jobs of automation of manufacturing industries. No? So basically looking at the increase in the stock of robots in manufacturing industries in this period for which we have data, which will be from 2000 to 2014. And using multi-regional input-output techniques, we try to capture the direct impact that this has in employment at the country, in the industry, and in different countries, but also the indirect impacts, no? Because the incorporation of a machine in one manufacturing firm, yes, it can reduce employment in that particular firm, but on the other hand, it will have another host of indirect effects, which can create employment in other firms in the same sector in the same country, in other firms in other sectors in the same countries, or even in other firms in other countries. And what we find when we take into consideration all these effects is that at the global level, once all channels are considered, in fact, what we see that there has been the increase in this stock of robots between 2000 and 2014 had led to a growth in employment of 3.4%. It's not huge, but it's not negative. So I think that is very interesting finding. And most of this increase in employment came from this sort of GVC supplier linkage effect, meaning suppliers that are in other countries and supply inputs to those countries which are increasing the level of automation. And more interestingly, the majority of this effect is taking place in emerging economies. So emerging economies supplying inputs to, for instance, the Germany, the US, or the Japans, which are automizing the production and therefore increasing their production. So this is just to say that we need to consider all effects when we want to analyze this part. And also, even at the firm level, in the survey that we have conducted, we have asked one of the questions is, what is the expectation in terms of these technologies creating, destroying, or keeping the employment level at the same level? And what we see is that when we take all the responses, all the firms, most of the firms, they expect that this technology will either increase the number of jobs that they have at the moment, or they will keep the same level of jobs. And why so? Because there is also the expectation that these technologies will increase the profitability of the firms, and therefore they will be able to expand. So then by expanding, either they will keep the same number of jobs or they will increase jobs. So this is then something to be debatable. And in terms of the sustainability of environmental sustainability that these technologies can bring, again, we have done analysis looking first at the sort of global level, and what we have seen is that these ADP technologies tend to have what is called a green content, which is above the average of all patents that there are in all technological fields. So this is another interesting finding. So ADP technology patents tend to be greener than other technologies. And also, again, when we look at the micro level information that we have collected for the report, we also asked to the firms, and in particular those firms which are already engaging with ADP technologies, to what extent they think that this will have an impact on different dimensions of environmental sustainability. And most of the firms, they tend to indicate that these technologies are expected to have a positive impact on all these dimensions of environmental sustainability of the firm. And last point that is more interesting for the current context in which we are now making this discussion, what we tend to observe also is that these technologies seem to help industrial resilience. And this is based on information we have been collecting since the start of the pandemic. We have been running surveys in manufacturing firms around the world, in different developing regions, Asia, Africa, Latin America. And one of the things that we are analyzing is to what extent firms which claim to be already using digital advanced generations of technologies in their production have been affected less than the rest when it comes to the impact of the crisis. So basically what we are seeing here in this figure is what is the difference between the expectations of profit decline in each firm during 2020, and we are comparing those which are digital advanced and the rest. And what we find is that the green ones, which are those which are digitally advanced, in all these countries where, I mean, these are countries where we have collected the data in these last months, tend to have a perspective that the profits will decrease less than the average. Now, this doesn't mean that the profit will increase, but as compared to the average, they tend always to have less decline in profits than those which are not actually adopting this digital technology. So again, a finding hinting to that direction. Digital technologies also might support the resilience of industrial firms. Now, moving to the end of this presentation, then the last question was, okay, how can developing countries capitalize on these opportunities for the way forward? No, we have seen, also Lili was pointing to a number of risks that are there, but then the question is, okay, how can they make the best from this technology? The technologies are out there, they came to stay, so now we have to think how developing countries can actually benefit from them. And one key challenge that we have identified, and I have tried to show in the previous slides, is that in developing countries, we tend to see this very high heterogeneity, this situation in which there are these modern islands of firms which are already adopting these technologies, but they coexist with the sea of firms which are really lagging behind. So then one key challenge ahead is how to help those other firms to enter into this new technological revolution. And based on an extensive review of policy responses that have been already put in place by different countries to deal with these technologies, in the IDR we identified 3 areas which seem to be specifically important to achieve this goal. First of all, building framework conditions. I think this will not come as a surprise to anybody. We have seen ADP technologies adoption require important efforts in developing these framework conditions, which are related to regulations, and this is a point that Lili was mentioning before. Regulations are very important, but also digital infrastructure, also the institutional infrastructure. That means the who in the government is going to deal with that and how it's going to do it. And also very important in view of the fact that these technologies are so concentrated in the world, and we have 10 players which are the ones that which are driving the whole technological revolution. International collaboration and technology transfer with those players is fundamental. So this is very important. Now, even if the framework conditions are in place, countries still need to foster the demand and the adoption for these new technologies. On the one hand, they need to help accessing these technologies, making these technologies affordable for especially the small and medium enterprises, but also they need to support the awareness of firms regarding how these technologies can be used and why they will be beneficial. No? So there is an important role of trying to bring information about what are these technologies at the level of the firm. And finally, for firms to be able to adopt these technologies, they also require to have the skill and research capabilities in the country. So therefore, it's fundamental to strengthen the human resources, to strengthen the skills, and of course, to strengthen also the research capabilities in relation with these technologies and in relation to the productive absorption of these technologies at the level of manufacturing firms in the country. So now to finalize and to provide some elements for the discussion that we will have right after this slide, let me just mention 3 takeaways I think that might be coming from what I have just presented. First one, Industry 4.0 technologies can become key drivers of industrialization, but, and this is very important, their diffusion is still very limited and highly concentrated. And this happens both at the level of the world. We have seen these 10 economies explaining most of the creation and production of these technologies applied to manufacturing, and also within countries where we have seen that at best 5% of the economy of the firms in developing countries, but this also is the case even in advanced economies, are using these technologies. Second takeaway is that building and strengthening industrial capabilities is a prerequisite for the productive absorption of this technology. No, and this again points to the fact that far from losing importance, and of course I cannot say something else coming from UNIDO, industrialization remains as a major avenue to embark in ongoing industrial revolution. And I think this sometimes comes as obvious, but apparently it's not that obvious for some observers. And finally, and this is also a clear conclusion from what we have been analyzing so far, is that developing countries need to foster the adoption of these technologies by manufacturing firms. And one way of doing so is trying to develop and strengthening an ecosystem that facilitates the adoption. And this will be fundamental, I would say, not just to achieve the catch-up with the countries which are today at the technology frontier, but at least to avoid making this gap with the more advanced countries becoming wider and wider and wider. So this is a sort of a condition, at least not to lag further behind. So thank you very much for your attention. And if you might be interested in knowing more about this report, you can find it here at unido.org/IDR 2020. Thank you very much.
Thank you very much, Alejandro, for this interesting presentation. We can now open the floor for questions from the audience. So please either post your questions on the chat or ask for the word. First, we have Dario, who has some questions for the speakers. So Dario, would you like to open the microphone and ask your questions?
Yes, no problem. Thanks. Thank you very much, Alejandro and Lili, because your presentations were wonderful, very thought-provoking. I have lots of questions, but I will try to make some focus on two specific questions that are three, sorry, that are very interesting to me to know more. One is for both of you, that is simply that there are some authors that assume or that erase that this fourth industrial revolution is not an industrial revolution. It's more like a deepening of the third industrial revolution. And for me, this question is very important, especially for developing countries, because if it's not a new industrial revolution, I think it's more probably more likely that developing countries cannot take opportunities of this, and maybe the countries that have capabilities and from your opinion on this discussion. Sorry, can you hear me?
At some point you were freeze, so if you want to repeat the last part.
Yeah, I was saying that some authors raise that this is not a new industrial revolution, it's a deepening from the third industrial revolution. So I wanted to ask you, I wanted to ask for your opinion in terms of this, because I think it's very interesting for developing countries in terms that if it's not really a new industrial revolution, maybe it's more difficult to developing countries to climb or to catch up in these technologies, and maybe it's more easier to make some incremental progress on this technology for advanced countries. And the second question is more specific for Lili, that is, and it's also inspired that because I read your work on the technological trajectories on 3D printing technology, and you are and you raised that China and South Korea reach some positions to impose or to have an important participation in the new technologies of this paradigm. So I want to know if you can. You have the information, what were the policy initiatives of China or South Korea to really reach this condition, and what are the specific instruments or programs or whatever they did in these terms, because I think it's related also with Alejandro said on the initiatives from developing countries. And the third, very brief, is for Alejandro, and it's what do you expect in Unido, or what do you personally expect from for the next industrial development report to have, for example, the pandemic effect on this situation. That are the questions. I'm sorry for the time. Thanks.
Thank you very much. Maybe we can gather a couple of more questions and then we proceed to the answers. I have a question here from Henny saying it is possible to go back to the 3D printing technology slide from Lili and explain it a little bit more. I have some notes. Where do they stand for and what do the number and codes mean? And then we have also Beatriz who would like to ask a question. So maybe we can let Beatriz ask her question and then we do a second round. So. You're muted, Bea.
The most said phrase in the whole 2020 and 2021. Thanks for the presentation, Lili and Alejandro. My question is maybe more for Alejandro, because I was actually thinking what this means for, let's say, for developing countries' productivity. Because if what we're saying is that in a way you already have to be good at producing to be able to lead in these type of technologies, and they will have productivity gains. I wonder, yeah, what is going to happen in let's say, I don't know, 10, 15 years with the productivity of countries that are already laggards, maybe even in the adoption of very basic technologies. I'm thinking, well, in a way, low wages for many years were the main comparative advantage, and if they're even becoming more efficient and able to lower the costs, not necessarily through reshoring in this, I mean, not necessarily involving reshoring in these developed countries. What do you think could be some potential trajectories there for developing countries? Sorry, that would be my question. Thanks.
Great. So Lili or Ale, would you like to, who would like to be the first one in tackling the?
Okay. Lili, do you want to start? Okay, sure.
Dario asked very nice questions and quite a large number of questions. Yeah, very nice. First one, you mentioned the whether this is really fourth industrial revolution or not, or was the extension of the third one. Yeah, that's a good question. It depends on how you define the industrial revolutions. According to some people, this is the sixth industrial revolution. So, okay, no matter the third one or the sixth one, the main issue I want to stress here is it's crucial that each country's attitude and how countries are benefiting it. For instance, Alejandro mentioned the creation and adoption of technologies. This is quite important to answer your question of the catching up issue. So for countries to catch up, you do not need to really develop the technology yourself first. You do not really create the technology yourself, because that takes longer. And you can first benefit it by adopting such technology, like Africa. They're using the cell phone phones to do the transactions by business, so mobile money. So they have a lot for them. So developing countries can benefiting from such adoption of the technologies, and then when they have the more capacity, they can climb the ladder and then to create a new technology by themselves. So this is related to the catching up issue. Related to the 3D printing question, you mentioned the technology application in manufacturing. Yeah, for instance, like in emerging economies, they joined the trajectory only in recent years. So technologies, yes, technology-wise, they are capable to do so, but the application in the manufacturing is still we need to figure out. So there are no really good regulations yet how this should be applied. What does it mean? For instance, you can use the 3D printing even in medical area. You can have the organ transplant by the through the 3D printing. But then how that would be used, and then whether you feel safe or not. So those kind of things we need to still think to figure out, especially for the government, for regulation sectors. Yeah, this more or less, I think that's your question, right, Dario? And then I would like to go to the Santiago posted in the chat about the 3D printing technology. Yeah, first one, definitely there is a path dependence. Always when you talk about innovation, we always realize there is a path dependence because you need to develop your capacity first. And then you can reach a certain level, but sometimes if you are in the track, you always rely on your later one. Even quite path dependent, sometimes good, sometimes bad. But for new emerging economies, sometimes they do not have the history. Sometimes they can start totally new things. That's why in the later years, when you see the trajectory, 3D printing trajectory, you see more emerging economies there because they didn't have much history to rely on. So they start some new thing, can be even good. Yeah, and then so the adoption, yeah, again, the adoption, it will take a while. How this would be used in really mass production, we do not know yet. For instance, like a 3D printing, you can also have the bridge printed by 3D machine. We don't know yet. And another thing I want to mention is related to the 3D printing trajectory, why there are so many branches later on, much more than before, is that in the later years, you have more and more applications in different fields, in construction sectors, in medical areas, or many different sectors you can have. That's why you have different branches. So the second question, besides the concentration of 4.0 technology in a few countries, is there some kind of sector profile which makes some sector more prone to make? Yeah, that's indeed that's a good one. There are many different ways to benefit from such technologies. Like Alejandro also mentioned, the application of such a new innovation or technology doesn't necessarily mean that you will lose your job. In quite some cases, you can gain new jobs through such a new platform by using such new technologies. So that's quite related to the sectors, to kind of quite different from cross sectors. For instance, some science-based sector industry, or some can be supply-based, some can be market-based sector, so they can react very differently from such new technologies. So if you want to know that, how they really, how they should react to it, then we have to look into the different features of those sectors, different industry characters, and then we can find a more specific solutions for that. I think more or less I probably answered the questions. Alejandro?
Thank you, Lili. Yes, so you answered everything. I can go. No, sorry. No, let me also try to address some of the questions. First of all, thank you, because this is exactly the type of questions we wanted to motivate when producing the IDR 2020, you know, because I mean, we didn't want to paint a world that is everything colorful and flower. No, that's not the case. I mean, one of the main messages we wanted to give is that unless rapid actions are taken, the way in which the technological landscape and the global production landscape is shaping will go to a larger and larger divide. No, and then this connects mainly to the first question from Darío, but also the intervention from Beatriz. We run the risk that countries which are already least developed countries, or let's say low-income countries, even lower middle-income countries, we run the risk, a very concrete risk, that the gap between them and the rich countries, the one country, will be increasing further and further. And Beatriz was asking, okay, 10 years on the line, what would happen? Well, if we continue in this path, what would happen is that the productivity gap would be much, much larger, which means less opportunities for these countries to actually achieve the UN Agenda 2030, the SDGs, to close the gap with rich nations. So that means that we really need to take coordinated actions at the global level. And that's why the IDR 2020 tried to finalize with a call for action, calling the attention of leaders around the world that the international community needs to support these countries in the adoption of these technologies. No, and that doesn't mean that these technologies are per se good. What it means is that if they don't adopt these technologies, then they will start lagging further and further behind in terms of productivity, their competitiveness, and therefore their opportunities for achieving an industrialization will be lower. Now, that sounds very nice. Yes, international communities will help, but how? And that's, I think, where the big question comes. And I would like to relate my answer to that with the first question that Darío was posing, that was, okay, is this a new revolution? Yes or not? And I think Lili already answered very nicely. It doesn't really matter if we call it revolution or not. But what I think is fundamental is to understand that even these new technologies, they build on the same principles, engineering principles, technological principles of past revolutions. And the IT revolution is at the core. And it is difficult to think that, let's say, a factory in Ghana, which has never used a digital technology, they are not even using internet, they are not even using emails to connect with the customers, will be able to use, let's say, these machines which communicate with each other. No? So that's the problem of the gap. The problem of the gap is that you cannot even understand the technology in front of you. So that's why it's so important to start building capabilities from beneath. No? So first we need these countries to develop very basic capabilities on industrial production. And then they need to start trying to move upwards in adopting digital technologies. And something that we explore in the report, and I think that is an interesting contribution, is that these digital technologies, when you go to the level of the firm, can be implemented in different business areas. No? You can have digital technologies implemented in the production process. They can be implemented in the design of the products. They can be implemented in the relationship with the customer, relationship with clients. And you don't really need to put all these technologies in every business area of the firm. You can start incrementally. You can start step by step. And then the challenge there is to find ways to create domestic, simple solutions for local suppliers that can actually start adopting these technologies, increasing their productivity, and entering in these production chains of those big firms that they're already at the edge. And that's another very interesting finding from IDR. In the IDR, we don't see that countries are not using at all this technology. The problem is that only few countries, only few firms in a country are using technology. Even in Ghana, there were some firms which are already in this revolution. So now the question is, how do we make it happen that these firms will be able to find suppliers domestically which can start growing together with them? So then the big question is, how do we create ecosystems around those players that we already have that can actually trigger a process of fostering spillovers, fostering linkages, and driving the, I would say, not the whole country, but at least portions of the country in a process that will hopefully initiate something bigger. Okay, so we need to start by sparkling this in different clusters, in different portions. And that's where international support is fundamental, no? Because international support can help these countries to start strengthening these ecosystems and directing investment in that direction, in a direction of trying to build local suppliers, trying to enter in some specific value chains. And then, so let's say it's a mix of pessimism and optimism. No, let's try to be on the optimist side and let's say, okay, what shall we do so that these countries are not lagging further behind? And another, I think another key question that was posed in the chat by Santiago, that Lili already addresses, okay, but to what extent the productive structure of countries also shape this level of adoption and use of these technologies? What we find in the idea is that to a very large extent. So then if your country is already oriented towards certain specific activities, certain specific industries, then the chances that you will be able to master this technology are much higher. And let me just show you one figure, because as you might have already seen, I am a fan of figures, which is coming from the report. So I will just 1 second share this again now. Let me share this. Yeah, this one here. Yes. So you can see, yes? Do you see this figure here? Hello? Okay, I don't know if you're...
Yes. Yes.
Ah, you see it, okay.
Yeah, we see it, sorry.
Thank you, no, it's just that...
And now
so,
we don't see it.
But now you see it.
Great, yeah, now we see it.
This is again the importance of mastering digital technologies. So you can see in this figure what we have done is to also analyze these countries, the ones which are actively engaging with ADP technologies and countries which are not, and then relating this to the share of what we call technology and digital intensive industries in their production structure. And again, what you can see is that those countries we have a large share of this specific type of industries are at the same time the countries which are engaging the most with this technology. What are these industries? Well, these industries basically include, among others, automobiles, computers, and electronics. So are basically computer, electronic, and machinery, transport equipment. So countries which are more, let's say, directed their productive structure toward these particular industries have higher chances of benefiting from the opportunities of the new technologies. Now, does that mean that other countries cannot benefit from them? No, it doesn't mean that. But it means that when countries design their industrial strategies for the future, they should also keep that in mind. And then when trying to understand which sectors they should bet, they also should keep that in mind. So I think the challenges ahead are huge, but they're not impossible. And there are cases, there are examples of countries which actually managed to do this climbing of the ladder with directed industrial policies, and then with the support of the international community, this might happen. So I just want to keep an optimism on that. Thank you.
Many thanks for your insightful responses, very complete. Do we have further questions from the audience? Would someone like to
If I may, there was also one other question from Dario I didn't answer. Do we have time?
Yeah, absolutely.
Because that comes very handy. And actually, he was asking, okay, what about the pandemic and what about the next industrial development report? And this was not coordinated. I didn't ask him to ask that question. But in fact, the next industrial development report, the IDR 2022, which is going to be released in December, will exactly look into the pandemic, the effects of the pandemic on industrial development, and also what are the prospects for the future of industrialization. And then, I mean, one point that we have been understanding from the analysis we have been conducting is that, again, the importance of having a strong industrial sector come up very clearly, because what we are seeing is that controlling for all other factors which are actually in play here, countries which have stronger industrial capabilities tend to react better to the pandemic, have been able to weather the pandemic better. And why? Because these industrial capabilities help them to be in a position to respond faster. No? Because, for instance, one of the main issues at the beginning of the pandemic was how can you change your productive structure to produce certain goods which were fundamental for addressing the health emergency. Of course, countries which already had some of these capabilities in place were able to react much faster and do that. Other countries did not. And now we are seeing the same in terms of the production of vaccines or the production of medical equipment. So I think there will be a very interesting message coming from the next idea related to the importance of the industrial sector, the importance of building industrial capabilities. But again, and in this idea, we're also trying to help the international community to think, okay, what policies can be taken globally, you know? Because one point is that when we face situations like the one that we're facing now, these are global situations, industrial policies from countries, individual countries alone, are not enough. So then we really need to move to a scenario in which we also think global industrial policies. And these global industrial policies is something that is probably quite original, and we are working with a set of eminent experts, including Stiglitz, Jeffrey Sachs, Mariana Mazzucato, to try to come up with these ideas. Okay, what needs to be done, how this international policy coordination can take place. So I hope you will be able to read the report at the end of the year, but we are still working on that. Thank you.
Thank you very much for your answers. We have an additional question for Lorenzo, from Lorenzo. That says, thank you very much, Lili and Alejandro. Your presentations were really nice and inspiring. Do you think that ADP technologies could boost reshoring of manufacturing to developed countries and make it harder for developing countries to industrialize?
Yeah. May I add something here?
Mm-hmm. Yeah.
I think that's a very good question. Because I just finished one master course managing the fourth industrial revolution. In the course, we also discussed this question, and some of our students did a survey in the past, not by themselves, but together with some other organizations. In some countries, they checked when there were machines replacing human jobs. What should we do? So they gave two scenarios. One is to compensate for the unemployed people, give you some subsidy, give you kind of some money because you lost your job, kind of social benefit. Another scenario was to offer you some training, more education. And then they did the survey. Most people choose to take the social benefit, so take the money without taking the training. So this would answer your question. So it depends on the society, depends on the reaction of the people. If you are facing such a challenging machine replacing human job, and it's happening everywhere. But if it's in one country, no matter it's advanced country or developing country, if you take the passive way, if you think if you just want to take the the social protection without learning. And of course, then we can expect in the future, you will be lagging behind. That's why I think for some countries, especially developing countries, they should realize this. And then in quite some more cases, they should provide education to be prepared for the future instead of looking only at the current years. So that's quite at least that survey quite surprising for me. I think they did for not only one country, a couple of countries, they had that result. I think probably that would answer your question a little bit.
Let me just add one other fact, because yes, indeed, this is a very relevant question, and of course, it's a concern in all developing countries. I mean, it happened to us when we go to talk with policymakers in different parts of the world, but in particular in East Asia. That was a very big concern. So, okay, these new technologies. So those countries which actually achieve their industrialization through abundant labor force and therefore like playing with the competitiveness, wage competitiveness, they are extremely concerned about this, because if in the centers robots can actually do the job that before was done by labor-intensive countries, firms, factories will start moving back to the centers again. Big concern. But what we have tried to do also in the idea is to put some numbers on that. And then there is a very interesting source of data, which is the European Manufacturing Survey, a survey that is conducted across European firms, big firms. And one of the questions they ask is actually whether for those firms which have operations abroad in other countries, if they have decided to backshore their operations. In the last year, the data that we use, of course, was I think for 2017, 2018. But then what we found is that it's very small the number of firms which actually indicated that they have been doing backshoring. We were also connecting this question to whether the firm was introducing new technologies at home. And the number we got is that there was exactly 6% of firms in the sample of the European Manufacturing Survey have indicated doing backshoring. And what seems to be happening in these 6% firms is that, yes, they sort of backshore from remote locations. So they bring production back from China to Europe, but then they offshore to closer locations. So in a way, it seems to be something like a movement from China to Eastern Europe, for instance. And then when the question comes of, okay, what was the main reason why you are backshoring? The main reason very rarely is the adoption of the new technologies. It's not that the firm is saying, I am backshoring because I have put this new smart factory at home and I don't need any more this sort of cheap inputs coming from abroad. In fact, typically they tend to be more related to flexibility in the logistics or to the distance to the market to which they are trying to serve production. So that's why, especially in the case of Asia, China being one of the major emerging markets, is probably that for firms, even in this context of new technologies, they will still find it important to keep production there because they will be closer to the markets. So I think the concern is much more, at least today, in the public debate, but in the data is not yet something that we are observing, this massive process of backshoring. Thank you.
Many thanks. Actually, we were also debating among ourselves to what extent this was related to reshoring and thinking whether we should introduce a specific session on reshoring or not within this seminar. We are already out of time. Would anybody like to do a final question, or the speakers would like to say a final remark before closing the?
Yeah,
This
I really like this this platform. Really nice. Very nice discussion here. I just want to add one small thing. That the technology is like a two double-sided sword. Can help with the inequality and also can make the inequality worse. So it depends on how we are going to use this, such a technology, how we are going to take such opportunities. So yeah, so I think it's quite challenging, but if we are smart enough, we can manage it. And then I really like to thank everyone, thank Florencia, thank you for the invitation. It's really very nice to present here, and thanks for the questions, really very nice questions and provoking. Yeah, thank you.
Yeah, let me also thanks first organizer for this very interesting webinar. I think this is a great initiative, and I encourage you to try to continue. And if you want to add one session on reshoring, please go ahead. I think it's a very hot topic and very interesting. And secondly, I would really like to support and endorse what Lili just said. I think these technologies are double-edged swords, and it's not that much about the technology per se, but the way in which these technologies are being used and are going to be used. So I think they are already here, they're already with us, they have the potential to do a lot of good things, but also they pose challenges for not only developing countries, also advanced countries, for the world itself. So I think it's very important to try to come up with solutions that will help the good use of these technologies, meaning the use of these technologies in such a way that will help reducing poverty, reducing inequality, reducing between country inequality. Thank you very much. I think it was a very interesting discussion and webinar. Thank you.
Thank you very much to you for presenting and for being so engaged in participating in this first webinar. I think it was a great. We counted with two great presentations and also with great questions and discussions. So again, thank you very much.
Sorry, I just want briefly to promote a conference that we are organizing from the Economics of Innovation Working Group at YSI together with Institute for Innovation and Public Purpose of the University College London. I will put here the link so you can see by yourself, but it's another event that we are organizing, so just that. And thank you both for your presentations.
In light of announcements and promoting, I would also like to promote our next webinar on the Industry 4.0. That it's the topic is patterns of adoption of Industry 4.0 technologies in developing countries, and we are going to count with the presentations by Marcela Amaro, Hernan Morero, and Fiona Trejena. And it's going to be held on the 24th of June. So you're all very welcome to join. And thank you once again to the presenters and on the audience for participating in this first webinar. So I wish you a good day or evening, depending on where you are.
Yeah, thank you.
Thank you. See you soon.
Bye-bye.
Bye. Thank you very much.
Bye-bye. Thank you.
Thank you. Bye-bye.
Thank you. Bye-bye.
Bye-bye.